It's 50 past the hour. You know what that means, right? A little late, but yeah, it's the bell. It's time for Weather Classroom. It is in session right now. This hour, we have a really cool lesson on how volcanoes create weather. Joining me now is Alexa Van Eaton. She's a volcanologist and geologist with the USGS Cascades Volcano Observatory. Alexa, thanks for joining us. Let's start off with the Ring of Fire. And this is where some of the most active volcanoes in the U.S. as well as the world kind of reside. So talk about that area.
Hi, everyone. My name is Alexa, as Paul mentioned, and the Pacific Ring of Fire is a region of the Earth where there's subduction happening. And for all of us who might remember plate tectonics in school, what subduction means is that the oceanic crust is subducting beneath continental crust. And that creates molten rock under our very feet and creates a place where volcanoes can start erupting. So there are over 1,500 potentially active volcanoes in the world, and many of those are actually located right here in the USA.
That's right along the Ring of Fire. And we have some like in, say, Hawaii, where the eruptions aren't usually explosive. But what makes a volcano give perhaps a pretty wild and explosive eruption, and how long can these eruptions last?
Absolutely. So, what makes volcanoes actually become explosive is water. So this is the Weather Channel. We talk a lot about the water cycle and how there's rainfall and precipitation and evaporation, but actually on timescales of millions of years on the dynamic Earth surface, we have volcanic processes that are subducting water. So as we talked about how we had the oceanic plate subducting beneath the continental plate, that is a place where water gets subducted deep below the Earth's surface. And that helps the molten rock develop. So actually what's happening in a magma reservoir is that the water that's in the magma is under really high pressure. So just like a Coke bottle, when you release that pressure by allowing the magma to ascend, the water comes out of solution. It turns into gas. And just like we heard from the Coke bottle, that pop, a volcanic eruption explodes when the water vapor expands and breaks the rock apart. So that is a process that's happening both in Hawaiian style eruptions like we saw in 2018 and even more highly explosive eruptions like we saw in 1980 during the Mount St. Helens eruption in Washington state.
That's what's going on the ground. Let's talk about the sky here, because sometimes these plumes are called like pyrocumulus clouds, but they also create lightning. Talk about how the volcanoes can create lightning as well.
Absolutely. So when that explosive eruption happens and fragments the molten rock into tiny pieces called volcanic ash, all of those billions of microscopic ash particles are shot into the air. It looks like smoke, but it's not smoke. It's actually tiny particles of rock. And so what's happening is that those particles are scraping together at high speed. They have really high collisional energies. And so the particles start to steal electrons from each other. In the same way, an experiment you can try at home is to take a balloon and rub it on the top of your hair. And what you can see is if your hair is dry, a static charge will start to create where you can see your hair standing up on end. The same process happens in volcanic eruption plumes that are full of ash particles, where we get a static charge develop between those individual particles. But that's not the only way that lightning can develop inside an eruption plume. If the volcanic ash cloud rises high enough up into the atmosphere, the water that we talked about that was driving the eruption and in the magma turns to ice. And so the ice formation process also helps to trigger extra lightning. And so you end up with these two different ways that a volcanic eruption plume creates lightning, both from the particles rubbing against each other and from ice formation really high at high altitudes inside the volcanic cloud.
Wow, great information, great energy. I love your explanations. That's Alexa Van Eaton, a physical volcanologist and research geologist with the USGS Cascades Volcano Observatory. Thanks for joining us on this Sunday.